right, so in this section we're going to be looking at inverse relations. So first of all, you can notice that we have just a regular relation right here, which pairs elements of the domain with elements of the range. This is called a mapping diagram, if you remember from earlier in the year. An inverse of a relation basically switches the domain and range. So if the regular relation pairs A of the domain with B of its range, the inverse undoes that relation and pairs B of the domain with A of its range. So you can see that the domain here has become the range of the inverse, and the range of the original is now our domain. So basically they just flip-flop. The domain becomes the range becomes the domain. So when we're given a relation as a set of ordered pairs, if we want to find the inverse, all we have to do is flip-flop the x and the y values. So we're just going to switch these around. So the inverse, the x values will be -2, -1, -1, -2, whereas the y values will be -1, 0, 1, and 2. So all we do is flip-flop the x and the y. They then ask us to graph m and the inverse. Now on your homework you'll notice there are multiple choice questions since you don't have graph paper. The regular relation we will use a closed circle, and then for the inverse we'll use an open circle. So all I did was I just plotted these points. So -1, -2, put a dot, 0, -1, 1, -1, and 2, -2. So these solid dots represent the regular relation m. And then to graph our inverse function, we'll graph these coordinates. So -2, -1, -1, 0, -1, 1, and -2, 2. Again, I used open circles. You can also use x's, something that just looks different than the regular relation. Part 2 asks us to describe how the line y equals x is related to these two graphs. So for the equation y equals x, that's really y equals 1x plus 0 if you need to think about it in slope-intercept form. So our y-intercept would be at 0, and then our slope would be up 1 over 1, up 1 over 1, as well as down 1 over 1, down 1 and over 1. So what do we notice is the relationship between m and the inverse in regards to this line? Well, it kind of looks like it's been folded almost like a line of symmetry. So the line y equals x is a line of symmetry between the regular relation and its inverse. You can also say that the points of relation m have been reflected across the line y equals x. So again, you can see these are like the same units away on either side, and they've been reflected across that line. They then ask us, is m a function? So m is our solid dots. How can we test if something is a function by looking at the graph? The vertical line test. So remember, the vertical line test is where we would draw vertical lines through the points and see if they touch one or more points at a time. So just looking at the solid dots, if I were to draw vertical lines, they only hit one point at a time, so we would say that yes, m is a function. Now we look at the inverse. The inverse is our open circles. So if I use the vertical line test here, notice it fails. It hits 2 points at a time. So we will say no, the inverse is not a function. So you can just use the vertical line test all the time to test whether it's a function or not, but I'm also going to teach you today something called the horizontal line test. So the horizontal line test can help you determine whether the inverse is a function. So you would actually use the horizontal, which means going this way. The horizontal line test gets used on the original function. So remember, m is our original function here. So if I use the horizontal line test, see how it fails? That tells us that the inverse is not a function. If you don't like this, you can just use the vertical line test for both individually. But if you want, you can use the horizontal line test on the original relation, and that will tell you if the inverse is a function. All right, now to graph the inverse of a function, we have two options. You can either reflect each point across the line y equals x. That's useful if you're really good at graphing and you don't need a table of values for your graphing calculator, if you just know what this will look like. The majority of you will want to do the second step, which says, or you can list the coordinates of the function and reverse the coordinates to find the inverse. So number 5, we have a quadratic. Now we should know that that's going to make a parabola shape. It's going to be an upside down parabola because it's negative. But a lot of you will want to use your graphing calculator to assist you in this. So on our graphing calculator, we'll press our y equals button. I'm going to go ahead and clear out anything I've typed in. And we'll type in the equation. Negative 4x squared minus 1. Always start out with zoom 6 as a good window. And as you can see, it is a downward facing parabola. Now to be able to put this on our paper, I think we want to use a table of values. So remember, to get the table, we press second graph to get our table. Now I'm going to go ahead and list the coordinates that I think will fit on my graph. It looks like negative 1, negative 5 will fit on the graph. 0, negative 1, and 1, negative 5. We'll go ahead and fit on my graph. So go ahead and jot those down on your paper and label that as the original. And then I'm going to go ahead and graph the original on my coordinate plane. So let's just go ahead to negative 1, negative 5, put a dot, 0, negative 1, and 1, negative 5. And then go ahead and connect those dots this time because it was an equation. We should get a parabola looking like this. Now, to find the inverse, remember, all the inverse does is it undoes the domain and range. So all I have to do is I need to switch the x and the y coordinates. So the inverse, which again I'm going to use an open circle for, when I switch those values, it will become negative 5, negative 1, negative 1, 0, and negative 5, positive 1. So go ahead now and plot those points. Negative 1, 2, 3, 4, 5, negative 1, negative 1, 0, and negative 5, positive 1. And then go ahead and connect those with our dots. And you'll notice I used a dotted or a dashed line to represent the inverse just so it looks different on my paper, but you don't have to do that. Your homework is going to be multiple choice, so you'll just be selecting the correct graph from a set of 4 graphs. All right, if you'd like to, go ahead and pause the video and you can try number 6 on your own. Oh, sorry, we need to answer these 2 questions. Is the original graph of number 5 a function? So was the original one a function? Would it pass the vertical line test? Yes, it would. How about the inverse? Is the inverse a function? No, it would fail the vertical line test. So the answer for that one is no. Remember, I also mentioned that horizontal line test, which we could use for the inverse. If you test the horizontal line test, it fails. Remember, that tells you that the inverse is not a function. So now if you'd like to, you can try number 6 on your own, pausing the video. Otherwise, if you'd like more practice with me, just stay on. Again, I'm going to use my graphing calculator to assist me here. Typing in the equation 2x squared minus 4 and going to my table function. Again, I'm going to copy down any of the ordered pairs that I think can fit onto my graphing space, so probably negative 2, 4 all the way up to positive 2, 4. I'll just copy those down on my paper as my original. So again, we can go ahead and plot those on our graph. Negative 2, 4, negative 1, negative 2, 0, negative 4, and so on. Go ahead and connect those dots to make your parabola. Again, for the inverse, all we have to do is switch the x and the y around. So the y column goes in the x column, and the x column goes in the y column. And we'll go ahead and plot those. Again, this time I'm going to use an open circle for the inverse. So we should have 4, -2, -2, -1, -4, 0, -2, 1, and 4, 2. So these are kind of like overlapping parabolas this time. Same questions. Is the original graph a function? So the solid one, is it a function? Yes, it is. It passes the vertical line test. Is the inverse a function, the dotted line? No. This would fail the vertical line test. All right, the next thing we're going to do is we're going to find the inverse without a graph, when we're just given an equation. So if we're just given an equation, what we're asked to do is to interchange or switch the x and the y variables. We will then solve it for y. So that's the very first thing we're going to do. We're going to, number 1, switch the x and the y. So we're going to change these variables and put them in opposite spots. So our first part of the equation will be x equals 3y minus 10. Our second step then is to solve for y. So if I'm solving this equation for y, I first need to undo subtraction of 10 with addition of 10. To get me x plus 10 equals 3y, we then need to undo multiplication of 3 with division of 3. And at that point our 3's cancel, and I would flip the equation around so that y is on the left. And there's two ways you can write this. You can either put just x plus 10 over 3, or you can split it up and make it 1/3 x plus 10/3. I don't care which way that you write that. Then they do ask us, is this a function? So most of you will just benefit by thinking about, what does this look like? This is a linear function, or this is a linear function. Has a positive slope and a positive y-intercept. So it would be a line, something like that, looking like this. Would this pass the vertical line test? Yes, it would. So this is a function. You also could graph this in your calculator if you wanted to and see what it looks like. All right, our next example is a quadratic. Start out with the same steps. Switch the x and the y variables. So put x over here and y over here. And now solve this for y. Now I know y is squared, but the very last step will be to get rid of that square. We first need to isolate that. So I need to undo addition of 4 with subtraction of 4. Then I need to undo my multiplication of 3 with division of 3. These will cancel each other out. And our last step then is to undo a square with our square root. Now the biggest mistake I'll see is you guys forget your plus or minus. Need your positive and negative symbol. As soon as you draw that square root symbol in. So our answer should be y equals positive and negative square root of x minus 4. Now let's show you what that graph looks like on our calculator. Going to our y equals, we can type in the square root of, now you'll need parentheses around the top, x minus 4, close your parentheses and divide by 3. Now for the negative square root, I'm going to put in my y2 negative square root symbol. Again, group your numerator, x minus 4, divided by 3. Make sure the division of 3 is underneath the radical, just like it is in my graph. Go ahead and press zoom 6. And then you should be able to see that this is like two little pieces. One of them is shooting upward, the other one's shooting downward. I always call them like a shooting star. They're making that sideways looking parabola. So would this be a function? Does this pass the vertical line test? No, it does not. So the inverse is not a function. Remember, you can also use the horizontal line test. The original function was a parabola. If we use the horizontal line test, it would fail. That tells you that the inverse is not a function as well. And then the last one in this section looks a little different. First of all, it doesn't have a y. It has an f of x. Remember that f of x is the same thing as y. So the first thing you want to do is change that to be a y. So make it y equals 2 minus 3x squared. Now to find the inverse, we will switch our x and our y variables. So let's just swap these out to get x equals 2 minus 3y quantity squared. Now to solve this one, the first thing we have to do this time is, because it's a quantity being squared, we have to undo that square with a square root. So I'm going to square root both sides. Again, as soon as I do that, make sure to put in your positive and negative symbols. This square and the square root undo one another. So it would just leave me with my 2 minus 3y. Now I'm still solving this for y. So I first need to undo addition of 2, because 2 is an imaginary positive, with subtraction of 2. When I do that on the left side, I'm going to put it in front of the positive and negative symbol. I then need to undo multiplication of negative 3 with division of negative 3. Now at that point, you can simplify this a little bit further. These two negatives can simplify to be a positive 2/3. And this positive and negative divided by a negative would still be a positive and a negative. So our final answer should be that f negative 1 of x, and I should mention this is the notation for the inverse. It looks like a negative 1 exponent. We'll see this on the next page of notes as well, but this is the inverse notation if it was originally a function notation. Make sure we have our positive and negative symbol here. Now again, if you'd like, you can use your graphing calculator to verify the graph there. I have mine sketched off onto the side, but this would be 2 plus the square root of x. Now this time you want to arrow out, and actually I should put parentheses around that. Let's group that and then divide by 3. And in the bottom we'll do parentheses 2 minus the square root of x. Arrow out of the radical, close our parentheses, and divide by 3. And you can see that this makes that sideways looking parabola because of the positive and negative symbols. This is not a function. It is failing the vertical line test. All right, and on the day 2 notes, we're continuing this relations and functions. Again, I noted in the notes, the inverse of a function f is denoted by f to the negative 1. Again, the inverse may or may not be a function, it just depends. So number 10, consider the following function. F of x equals 2x plus 3. Find the inverse. Again, this symbol right here just stands for inverse. So to find the inverse, the first thing I want to probably do is change that f of x to a y equals, just because that's what we're used to seeing. And then we switch our variables around. So plug the y in for x and the x in for y. So switch those. Now solve for y. What would I do first? Undo addition with subtraction. Then undo our multiplication with division. So we should get y equals x minus 3 all over 2, which again in function notation is f negative 1 of x. equals x minus 3 over 2. You also could write 1/2 x minus 3/2 if you prefer. Now, is this a function? What would this look like? It's x to the first, so it's linear. Has a positive slope, 1/2 x. So a positive slope means the line's going up. Would that pass the vertical line test? Yes, it would. So that is a function. And then for part C and D, they want us to find the composition. This is using stuff we learned in 7.6 last week. Now, they want us to find f of -1 of 2. Remember, for function composition, we always start on the inside. So we're going to find f, the inverse of f, of 2. So we're going to take 2. We're going to plug it into this function we just found. So 2 minus 3 all over 2 is -1/2. So now we can get rid of this. And this will be f of -1/2. Now to look back at what the original f of x function is, I do need to scroll up. My original f of x function was given 2x plus 3. So I'm using 2 times -1/2 plus 3. 2 times -1/2 is just -1 plus 3, and we get 2. Now notice the question was find the function of the inverse of 2, and we got 2 as our answer. So I wonder if that's always going to happen, if maybe it's always going to get us back to the number they asked us for. So let's try one more and see what happens. So part D asks us to find the inverse of f of 3. So we're going to start out with f of 3. So we're going to plug 3 in to this function, the original. So that'll get me 2 times 3, which is 6, plus 3, which is 9. We're then taking that 9 and plugging it in the inverse function. So let's go up and look at what we found out was the inverse function. That was this. So it'll be 9 minus 3 over 2. 9 minus 3 over 2, which gets us 6/2, which is 3. So look at that. This number came back out to get us the same thing. The reason for this is that taking the inverse of a regular function undoes that function to get us back to the input. So you won't have to do all this work anymore. We now can conclude that if you're taking the composition of a regular and its inverse, it'll get you right back to that number. All right, go ahead and pause the video if you'd like and try number 11 on your own. If you'd like to keep paying attention, just follow along with me. So again, in number 11, the first thing I usually do is change that f of x to a y. Now notice this one again has a parentheses being squared. So we first need to switch the variables, of course, plugging x over here and y over here. We then need to undo our square with a square root. Don't forget your positive and negative symbols at that point. And lastly, we need to solve for y. So to solve this for y, I need to first undo addition of 2 with subtraction of 2. Then undo multiplication of -3 with division of -3. Notice here that the two negatives here will cancel each other out to get us a positive 2/3. Is this a function? Remember, the positive part of that square root graph is going to give us a positive shooting star or part of a parabola. The negative part of that is going to give us a negative shooting star. It's always going to make that sideways parabola, which we'll actually see more of in the next section. But if you're not sure, you can type it in your calculator to verify. This is not a function. And then our last two questions, we can use our shortcut, just knowing that if it's the function of its inverse, of a number, we get that number right back. So it should just be 2. And the inverse of a function of a number should be 3. Last thing we'll take a look at is word problems. With word problems, we'll be seeing formulas. Formulas have letters that represent specific variables. So when finding the inverse of a formula, you want to keep the letters the same. Don't switch the x and the y or anything. But you will keep the letters the same and just solve for the other variable. So in example 12, we have a function distance equals 16 times t squared, which models the distance d in feet that an object falls in t seconds. Find the inverse of the function, and then use the inverse to estimate the time it takes an object to fall 50 feet. All right, so again, for the inverse, we're not going to switch the variables, leave the d and t alone, but we're just going to solve this for the other variable t. So to solve for t, I right now see multiplication of 16, so I'll start out with division. And then lastly, we will square root both sides. And you really don't need your positive or negative symbol this time because it's time, which can't be negative, but I'll put it in for right now. You can either leave it d over 16, or you could take the square root of 16, which is 4, which is probably a more correct answer. So that's my inverse. Then they ask us to find the time it takes for an object to fall 50 feet. So we're going to plug 50 in for d. And then we can use our calculator to get a decimal approximation there. So we'll have the square root of 50. Make sure you arrow out of the radical before you divide by 4. So 1.8, 1.77, something like that. And that will be in seconds. Notice time can't be negative, so we're only looking at the positive. If you want, go ahead and pause the video and try number 13 on your own. If not, stay on and you can watch me do this one for you. This one is a function that is relating distance, d of a stone that has fallen in feet, to its velocity in feet per second. Find the inverse and use that inverse to find the velocity of a stone that has fallen 30 feet. So again, for this one, leave the variables right where they are, but we're going to solve this for v. So I see division of 64. The inverse of division is multiplication. So I would multiply by 64 on both sides. Then the inverse of squaring is square rooting. So I'll get positive and negative the square root of 64d, but the square root of 64 is just 8. So I simplified that. And they ask us to plug in 30 for d. And again, we can use our calculator to compute this for us. 43.82. And that unit for velocity is feet per second. You can either write it out in words, or you can use this abbreviation. And then our last two examples should be the easiest ones because we just proved this composition of inverse functions on the front. If we are taking the function and its inverse and we are using composition, which is plugging one into the other, any number that you're finding will get you that number right back because these undo one another. So if you're finding the inverse of the function of 652, these two things basically undo one another, and we just get 652. Same thing works if you switch the order. If it's f of the inverse of negative square root of 86, it's just negative square root of 86. No work required. And that last one, same thing. We have an inverse of a regular of a number, gets us back to the number because those undo one another. And a function of the inverse, back to that number. Perfect, and now you are to complete the 7.7 homework assignment as well as the 7.7 mini quiz. If you have any questions on the homework, please email them to me and I will post short videos going over those examples.